So friends, welcome back. In this session, we are going to understand the classification of hardware trojans. First, we'll start with trigger-based and payload-based trojans. The trigger-based trojans gets activated under specific condition. The condition can be anything like an input pattern or an environmental factor or timing, or it can be anything. So for an instance, if you are giving only these commands 1, 2, 3 in order, that trojan could get activated and it can alter the data, leak the data, or disrupt the flow, or anything can happen. So it's under specific condition, this particular trojan get activated. Next is payload based. It is going to focus on executing a specific action which is definitely harmful, which can be like the data theft or the disruption once activated. So for an instance, in a banking application, in a banking chip, a trojan can jump in, and when it is activated, it can go ahead and transmit all the necessary data, all the very important data to the attackers for the misuse. So that is payload. Next comes the classification based on insertion phase. It can happen during three different phases. One is design time, second is manufacturing time, third is testing time. The design time is very dangerous. Embedding a trojan during the design phase itself is very, very critical. That's very dangerous. So they get deeply integrated into the circuit and they are very hard to detect. So that trojan, which is going as part of the design phase, gets into the microprocessor for an instance, and it can alter the instruction execution at certain conditions, and that will become very, very effective. So it's very harmful, very dangerous. It's very hard to detect also. During the manufacturing time, a trojan can be inserted, and that's happening mostly through unauthorized supply chain access. There is some leak in the supply chain, thereby these kind of trojans can come in during the manufacturing phase. A tiny chip can get into the motherboard during the manufacturing phase through the unauthorized supply chain access. Thereby, it can grant remote access to the particular system through the tiny chip. We have got historical references. Supermicro motherboard case is the best example for it. You can read them. Testing time trojans are there as well. They are added during the post-manufacturing testing or firmware updates. Often they are getting activated under a specific test sequence. For example, when I do a specific testing routine, these trojans can get activated. And once activated, they won't keep quiet. They collect operational data for the attackers, and that's going to be opening the door for all troubles. And they can also be inserted at IP level, design level, or manufacturing level. IP level is far, far dangerous. The trojans are embedded in the IP core, the intellectual property core. So, whichever devices are trying to use the same IP, they will all get this trojan as part of it. It's part and parcel. So it's going to be a gift that's going to come all the way. You have altered the IP core, and that's going to impact all the microprocessors, all the devices that are going to carry the same IP. So that's going to be super trouble. Next is design level. When embedded directly into the circuit during the design phase itself, it becomes part of the blueprint. Whenever that design is followed for manufacturing or for replicating the microprocessor usage anywhere or microcontroller usage anywhere, it's going to be a problem that's going to go everywhere because of this hardware blueprint which carried the trojan by itself. So it can alter data, it can leak data, it can create multiple harm, and all those are a trouble. Manufacturing level insertion is interesting too. Trojans are added during the physical fabrication process. So you need to have a fantastic and proper physical inspection for detection, which is actually very tough as well. So you can have an extra chip on a server motherboard allowing unauthorized data interception, and somebody can find it only with proper physical inspection, and this unauthorized extra chip can be detected that way. So it can be at IP level, it can be at design level, it can be at manufacturing level. We will learn about the detection and the prevention techniques shortly. It's going to be interesting too. If you like the channel, the content, please subscribe. Thank you.